Hi everyone, welcome to the second session of 5G non-standalone series. Actually, in today's video, we are going to explain 5G non-standalone secondary node release procedures for both normal process or procedures and abnormal whenever you have a drop. And also, we will explore all potential 5G non-standalone drop failures, their causes, troubleshooting methods, and related parameters which can improve the 5G code drop rate in general for 5G particularly 5G non-standalone. And watching the entire video is recommended because this is like will make you understanding the signaling analysis, signal code flow in general, and understanding signal code flow is key for the analysis and also for the success of RF engineers. So moving forward, here this is today contents. First part, we're going to cover the secondary node release procedures for both normal and abnormal. Then we also will go through some of the signaling contents and so on. Then we'll be covering all the potential or possible root causes of retainability or code drop issues in 5G. Then we'll explain which KPIs, the main KPIs for the drop related, where you can identify the root causes of the drops or the causes, the main causes of the drops. Then we'll last by the 5G parameters and features or parameters that you can think to tune it based on your network. So this is will give you an idea about what kind of parameters you would like to look into whenever you are trying to improve your 5G non-standard drop. So let's move. So the first part today, as you can see here, this figure is speaking about secondary node release procedures for the normal release. As you can see, we have two figures here. One on the left, which is called secondary release procedures, but master node initiated, which means that the release will be initiated by the 4G or the master node. And the second one, it's through the secondary node initiated through the G node B. In general, we have multiple causes. We have many causes of the normal release. I have listed here the most common one, which you will usually see. And also, if you would like to go through the details, I will add a link in the description where it will have the Excel file exported from 3GPP, where this link will be showing all the radio net normal and abnormal releases with their description. So as you can see here in the figure on the left, that there is a secondary rule whenever it's being initiated by the master node B, the master node B will be sending to the G node B asking him secondary node B release request. I would like to release my secondary leg. So the G node B will sending the release request acknowledgement, and usually this release request acknowledgement containing the details like what kind of information need to be deleted. Then the node B will be sending to the URL configuration message, and this URL configuration message actually containing, for example, the B1 removal that I would like to remove all the B1 related thresholds and also what kind of cells need to be removed. So this is kind of information. And in case if any remaining data still in the GNode B need to be forwarded from GNode B to the inode B in order to continue completing the data. Once this procedure is being completed, there will be a path switch also that now the path needs to be changed from instead of the serving gateway sent to GNode B. Now it should be from serving gateway to inode B because we already released the secondary node and released the 5G in general. Then after that, once this is being completed, the inode B will send you context release from inode B to GNode B telling them already successfully we released the resources. Exactly same idea here, but this time the release is coming from the GNode B. For example, here GNode B sending is GNode B release required. Then the inode B will say, okay, it's confirmed. Then after it's being confirmed, it will forward the exact same information and will go through exact the same procedures. And the question here, when the master node will initiate the release and when the secondary node will initiate the release. As mentioned above here, you can see usually the master node initiate the release request and two major causes. First one called user activity or MSG mobility. I will go through these kind of cases in next slides. But user activity, for example, if you have an activity timer, if the activity timer is being expired, then the inode B will be releasing the secondary node, requesting to release the secondary node. But this user activity can be released by master node, can be requested to be released by secondary node. This is based on the parameters or network configuration. It can be either based on MN or SN. This is based on the configuration which you have in the network. So the secondary node and the MCG mobility, whenever the master node is doing handover to another node, probably which not an anchor, it will request to release the secondary node because it's not needed anymore, especially when you are moving from one 5G site to non-5G site. So this is called MCG, Master Cell Group Mobility, which is, if you remember the concept in previous video, We explained that MSG is for the all the cells under the master node. Then the secondary node is same, but it can be user activity, SSG mobility, secondary node, for example, and something called action desirable for radio reasons. This usually it's related. This will naming will be confusing for you when you see it. Like you will think it's abnormal. It's not abnormal. It's normal release. I will explain in detail in the next slides. We have many other causes, but this is what you mentioned here is the top. So let's move forward and see what we have for the inactivity normal release. Then also we'll discuss about the abnormal release in the next slide. Then we'll go through the details for each one of those. So here, as you can see, first the normal release here. Abnormal release will be exactly the same, but just the calls within the release request will be different. For example, here we'll have user activity, MCG mobility, and the abnormal release will have, for example, UE connection loss. And few procedures will be added only in the MN, where the UE will initiate something called SCG failure information. This is called secondary cell group failure information that they use reporting that I lost the connection with the GNB secondary node. There is a failure, so I would like to release, or I am not even this secondary node is not reachable anymore. So in this case, the NB will release the secondary node. So let's see. So now, as you can see in the left figure, it's exactly the same flow, But here in this, whenever the master node is going to initiate, the UE first initiating something called SCG failure information. This is SCG failure information having multiple causes. Can be ratch problems, and also can be, for example, many other causes. For example, T310 expiry, maximum retransmission, uplink and downlink for RLC. We'll explain all these causes in the next slides. So this is the first information which is different from the normal lead. Here the UE will report, I would like to release this because I have a failure with the secondary node. So I'm not either the UE connection lost with the SNLB, but in general, now the connection lost between UE and secondary node. So here we'll be reporting, and within this message, it will state what is the cause. For example, here it's stated secondary SCG, secondary cell group failure information is random access problems. I have a random access I cannot access. I will show the signaling flow for this part in the next slide. Once this being received here, the eNodeB will forward this message with secondary node release request with this cause called radio connection lost with UE, and within the same message you will find this also SCG failure information called random access problem. Then the GNB will reply back with secondary GNB release request acknowledgement, and this is also will follow the same exact information which we have mentioned in the release. Here also this one will contain that to remove the B1 related events and also the secondary cell group. So this is, and it will continue the same. Here it's exactly the same compared to normal release, no differences except the cause within the SCGNB release required. And instead, for example, of being an activity, user activity, it will be, for example, this time radio connection with U lost. The causes for this radio connection lost with the U lost, this is usually it can be different causes, but for example the main causes it can be, for example, you lost the downlink. For example, GNB is forwarding data and there is downlink maximum RLC is being reached. I will explain this one in details. So this one also one other issue can be transport issues. I will explain this part. So this is just the general call flow for the abnormal. Whenever you have abnormal, this is what you're going to see. Now let's explore normal and abnormal release call flows for some of the examples which are shown. So next, for example, next slide here, we are showing that for this case, I'm showing the case where I mentioned that secondary node release procedures, the normal is due to action desirable for radio network. Okay, when you see this one, you might get confused. This is abnormal. No, it's not abnormal. This is a radio release, and this is usually only because of primarily because of the E2 threshold. We have E2 threshold, which is for removal of secondary cell. For example, if you look into this figure, in this case, we have E2 configured. So once you reach the E2 threshold, you are at the edge coverage of the SG node B. In this case, the master node will request the G node B here will request remove. It's know that already this particular user is below or worse than the E2 threshold. So it will send the node B release request from G node B to A node B, asking him to remove the secondary cell node. And this cause will be for the cause which is called action desirable for radio network. This will be including this information. And as you can see here, first the measurement report being sent, is including the A2 and other thresholds as well. For example, A5, A2 and A5. Then the RRC transfer will be sent because here the measurement report should be forwarded through the NLB unless you have something called SRP3 is being enabled. If this enabled, the measurement report can be directly sent from EU to GNB. But here I'm assuming SRP3 is not enabled. So here RSC transfer containing the information of the measurement report for A2 and other for example events, but usually for example A2 or A5 or whatever. So here is the JNB start making the calculation. It found that this E2 is below the threshold. So what's saying that toward the threshold, it's release the connection with this particular cause. So again, just like when you see this one, it's not abnormal, it's normal release because of E2 threshold. And this is the TGBB data, which is called the reason for requesting handover is radio related, and it's radio because the threshold is being below the value. So let's move for one more cause. Here, for example, here normally is due to MSG or SG mobility. This is whenever you have a handover, for example, you are changing even your master node. For example, in this example, you're changing the master node, or you are changing your secondary node. Here, this is just the exact code flow which I'm showing for the release in general. But if you look into here, if you zoom into here, this part, for example, here, this is during, as you can see, secondary cell change, MN initiated by the master node. For example, here the master node B was trying to change the secondary node. So send secondary node addition request from the master node, send it to the new target secondary node, and this one acknowledge what is being acknowledged. It will request from the secondary node, the source one. I would like to release the secondary because it's not any more needed because I already did an handover or I already made a change for my secondary node. So this code will be calling, for example, SCG mobility. So this is for sure it's normal release, it's not abnormal because it's just handover and it's being released as all the connection. And same for the MCG mobility. If you see this cause in the top right, this is as I mentioned, whenever there is a handover, for example, from one 5G site through the 4G leg. For example, 4G leg is making to from one 4G site to another 4G site, but the 4G is not anchor site. This is whatever I mentioned in the previous slide, in previous slide, but I mentioned as 5G anchor. But actually, it's handover from 4G to 4G, but the other 4G, for example, is not on the anchor side. That's why the connection will be released for the secondary node, and that's why it's called MCG mobility. Master cell group means 4G to 4G handover. And as you can see in the bottom right, also this is the description of 3GPP. And again, I will be attaching all the causes for the radio network layer causes, not only those, for everything we have about the release in general, either abnormal or normal. So let's move next. Next one is about the secondary general user activity. All of that is normal release. So this is the third common cause, and this is the most common one for sure. The most common one, this is whenever there is the unit B evaluated, for example, that already the in 4G activity timer. Let's say that you set the parameters network to release the secondary connection based on activity timer of the inactive timer of the 4G network. So for example, if the inactive timer is 10 seconds and once the user is in active state for 10 seconds, so in this case, directly the node B will send secondary node release request. And this is in case if the parameter is being controlled from the node B. But sometimes you will make the parameter to release that the unit B will measuring the inactive timer of the secondary node and it's being released. So in this case, unit B will be triggering the release as shown here. So this is based on activity such. So again, secondary release due to inactive timer in general can be triggered by MN or SN. And this is based on network parameters actually. Again, this is 3GPP definition. Now moving forward now, we'll start now going for the breakdown for the top root causes of the 5G code drop. This is the top root causes for the 5G code drop. You can see this figure in the left. This is explaining that, for example, here we have it can be done through 4G legacy. If you have a issue in the 4G, pure 4G issue, or core, or transport, or E, and 5G. And each one of those is being break down into several causes. Let's explain one by one. And here I just listed in the right same information that in general, the issues in the code drop can be due to 4G RF issues. For example, I have reestablishment, core problems, transmission, and so on. So now let's go through one by one. For example, the first one here, we are speaking about the 4G. In the 4G scenario, assuming you know that your 4G is your backbone or anchor layer, right? So if you have any problem in your 4G network, for example, your 4G like having a reestablishment for the RRC, and this reestablishment failed, and you have reestablishment being triggered, so this will lead into that you will have a drop. And this, in this case, who will initiate this part? The 4G already having the reestablishment from the UE. So the master node B will send, in this case, master node B will initiate the release, will send SSNB release request to release the secondary node because already there is a connection loss between the UE and 4G and the 4G node. And this is whenever, for example, you have a pure issue after for example, for sure the SSNB addition success. When you have a pure issue on the radio coverage or quality, and you have reestablishment issue, this will release your 5G as well. And this is initiated by the master node the release, and will be for sure your connection lost. The second cause can be about the 5G core. When this scenario, actually it's rare scenario, it's not happening that much, but let me explain what you will see. For example, you can see the figure on the right here. This is showing the accessibility which we explained in the previous video. The accessibility in general, after continuing the accessibility after the SGNB being added at this stage, for example, here SGNB addition request, sent, replied, then RSU configuration, and here we confirm it, then the ratch was completed. After that, you need to do this path switch changing. You remember? With that, you need to change the path to be, because this option 3x, so the path should be, instead of init B, the serving gateway send it to init B, it should be now the GNB start to, the serving gateway starts sending to GNB data. So this path switch is to change the path from init B to be to unit B. So this message will be sent from the init B, area modification indication, requesting the MME to change the path. So in case, if for some cases the MME was not able to reply, so this can cause a drop actually, because already here, this is considered as successful addition. So anything will happen after, even for random access. Yes, it's accessibility issue, but it will be counted as a drop. So this case will be counted as a drop in case if there is no reply at this particular area. And once this happens, there is no reply from the MME to the inode B. The inode B will send the SGNB release request, and probably this will be the cause we'll see it in this release request, which is called RRM purpose. And here this would be the acknowledgement from the GNB. So this is in case you need to contact and you need to communicate to the core network just to see what's happening, why the MME didn't reply at that case. And you need to go through maybe the IP, check which IP from the MME being sent in within the initial context set request, and all the previous message which we explained in the previous video. So now let's move to the next cause, which is about the transport. Now, this is the transport case. This is usually happening during the handover scenarios. Whenever you have any problem in your X2 connection. For example, whenever there is a communication between master node B and secondary node B, and somehow this communication is being lost, you can expect that, for example, you have some fault in the X2, or you have some problems with transmission in general, which causing X2 problems. For example, this is figure for the handover SGNB change and procedures in general. Here there was SGNB change required sent from S node, serving node to the master node. Then the master node requested here to make the addition, because here this one asked that this being triggered by SGNB, asking that I would like to change. So the master node B will here asking the target node, I would like to add you as my secondary node. So in this case, you might see a problem here, even here or here in the messages. Maybe there is no reply, and this might be because of X2, for example, connection down or transmission issue in general, impacting the transmission between the X2 connection between master node and other secondary nodes here. So this is also one of the causes, and also I didn't see that much, but it's you can see it from time to time. The cause number 4 is E2E, and this is sometimes you will find the E capability issues or defectives using the network, and this is can be seen. For example, there is some cases where directly after the HTTP addition, the user was triggering reestablishment. For one of the cases, for example, which I have seen before, that the user were able to add the SGNB will be able to be added by the user, but the user was not supporting the maximum combination of the bandwidth. For example, assume that you have two 4G carrier and one 5G carrier, and the bandwidth for this carrier is 200 megahertz, while the user only max supporting a max combination 150 megahertz. So this case was sending the user was sending directly RRC established. This is one of the cases, but there is a several cases which can trigger a drop after the SGNB addition, successful SGNB addition, which also can be ratch problems, configuration issues, many things related to the UE. Now, moving forward, the next one is about the 5G, and in 5G, we have multiple causes. The first one here, it's about the UE is in uplink out of synchronous state. This is we have one timer, which is usually infinity. I will be showing you the parameters, which is called uplink time alignment. Usually, if this one is setting for a low value and user lost the synchronization uplink, this can lead into the drop. But usually, by default, this infinity for many of the vendors, but maybe you need to check it in your network. But also, again, even if you have it infinity, doesn't mean that, or even having, for example, let's say 10 seconds or whatever, and you have this kind of issues, this also means that you might have a problem in general in uplink radio condition. The second cause here about the 5G, here, it's maximum number of downlink RLC transmission is being reached. As you can see, this one figure on the right here, this is showing that here the NDC setup completed, then we have batch procedures being completed, then the GNB start forwarding some downlink packets towards, and somehow the user start losing, it was not reaching, this packet was not reaching to the users due to downlink radio problems, or even can be uplink issues. The user cannot acknowledge these packets because of uplink, so it can be either downlink or uplink. So assuming you have a very poor downlink radio condition and you start having this kind of downlink packets being transferred, so there is a MAC retransmission of that MAC. It's followed by RLC. I have a video in details for that part. You can watch this video explaining how this mechanism is being working. So in general, this is if reaching the maximum uplink RLC, for example, downlink, sorry, RLC threshold. For example, assume you have it 8 here. So you have 8 RLC transmission, retransmission. Once being reached to the maximum threshold, then this means now the GNB will declare that there is a drop, there is a radio link failure, and it will be sending this SGNB is required because now this is downlink data, and this will be, as you can see here, the cause will be radio connection lost, and it will be confirmed again by the SGNB is confirmed, and the same procedures which being explained in the beginning will be followed. That will be RLC configuration sending from E B to the UE and so on. So this is one of the causes also. And as you can see here, this is both highlighted by yellow, by blue. This is secondary node will be sending. Secondary node, which means GNB. This is SNO. This is mean secondary node. This means the GNB will initiate the release because it's being triggered by the GNB itself. Now the next one, it's about the 5G. Many causes here, and all these causes will be triggered by the master node B through the UE. The UE have to report there is a secondary GNB failure with a particular cause, which is mentioning here. We have 5 causes here, and if any of these causes being reported from the UE, the node B, in this case, the node B will start triggering the secondary cell release, and because of abnormal release for sure. So let's go through one by one and see what we have here. So for example, the first one, it's about the ratch problems. In case if you have ratch problems, and random access in general can be during 2 stages, right? Even directly after the addition, if you remember in the previous also slides or even previous video, that directly after the HGB addition, which is being counted as accessibility substrate, the ratch will be starting. So this is, if you have a ratch issue, in this case, it will be counted as a drop. Also during SSL change, for example, it can also be counted as ratch is failing, so it can be counted as a drop as well. So for example, here I'm just showing the example here that after the NDC setup completed, the UE will start initiating the ratch process, which is message 1, message 2, message 3. This is complete ratch procedures here. So if any of those messages being failed, this means the ratch is being failed. So in this case, we assume that the ratch procedure is being failed. So in this case, the UE will be reporting SCG failure, as you can see here, with the cause of random access problem. And after that, the master node or node B will forward SGNB release request with cause UE connection loss, and within this one, it will state also that this is due to random access problem. And this after that, this the remaining procedure will follow as we explained previously. So for example, here is request acknowledgement, and this will be counted as a drop due to random access problems in the 5G side. Moving forward for the next one, it's about the, this is exactly the same as this one, but this time it's from the uplink. So for example, after the ratch process is completed, now the user starts sending uplink data, and somehow this data was not being reachable or not being acknowledged. It can be probably to uplink issues, but sometimes it can be downlink as well. The GNB is not able to reach or send the data and downlink acknowledgement for this uplink packets, but probably this will be uplink as well, and also for the ratch. So ratch can also be several causes, by the way, as I mentioned here. Link interference, ratch configuration, cell radius, no dominant cell, also can be during the handover as mentioned before. And the second one is about maximum uplink RLC. This is probably it will be due to uplink interference or uplink bad radio condition in general. So in the case this is all the maximum uplink retransmission for RLC is being reached in this case. So the user, for example, let's assume uplink RLC maximum threshold is 8. So you already crossed 8 retransmission. So in this case, the user will trigger SCG node B failure, which cause RLC maximum number retransmission. And once being sent here, again the node B will initiate the release cause, will also cause UE connection loss, and the UE connection loss will having also covering this particular region, which is called RLC maximum number. And here, this is as I highlighted all the time, these all causes is initiated by the node. Next one, actually, it's about the 3310 expiry. I have a detailed video, and this detailed video is covering the 310 and RLC. You can watch this video. I have added the link in the top right here. You can add this video. Also, I will add it in the video description. You can watch this video in case you would like to get the details. But simply that part, for example, there is a downlink packets being sent from GNLP to the IE, and somehow the user couldn't decode the BDCH channel for that part, or having high blur, and it was not able to decode this kind of information. So in this case, what will happen? There will be kind out of sync, and we have timer called T310, and we have another counter called N310. For example, this is if you have a number of consecutive decoding failures in the downlink, for example, let's say 3 times, then the timer will be starting. Once, if within this particular timer he was not able to make a consecutive, for example, A311 2 times successful decoding for the BDCH data, for example. So in this case, what will happen? The TT1s will expire. Once it will expire, then the user will trigger this kind of radio link failure. The user will send SCGNB failure again information, as you can, if you zoom in here, with the same, with cause T310 expiry, and then the same procedures will be following from NLB to GNB to try to release the connection. And this is also dropped due to T31 expiry. Next one actually, and this is usually it's during quality issues or even cover issues that can impact your black error rates, for example, for the BCH channel. So next one actually, it's about the synchronization failure here. This case actually, failure, this is usually whenever you have, for example, the user couldn't decode or find the information of SSP, can be due to different reasons. So he couldn't find or search for the SSP. In this case, this would be called synchronization or conversion failure. This is also will be reported by the user that he's not able to search or find the SSP, cannot make any synchronization. And also we have reconfiguration failure. This is usually conversion failure is probably categorized under a capability issue. Whenever you have any configuration issues in the network, this is will be categorized on this part. Not only the network and the UE himself have compatibility issues. It will be reported also as, for example, and sometimes it can be, for example, misconfiguration, for example, NSA settings and so on. But this is also rare cases. Usually, I see these 3 top causes as most causes in this particular case. Now, the next slide, I'm going to take you through the KPIs. Just quick visualization, what we can check in case you would like to identify some of the top sites or the top broad causes of the causes which you have it here, particularly for the 5G side. So as you can see here in this slide, this is just retainability identification from KPIs. The left figure here showing that, for example, what is the percentage of the drops initiated by the master NLP or secondary NLP? For example, you remember which I just explained here. The secondary NLP usually this is due to this kind of SCG failure reported by the UE due to this kind of problems. For example, reconfiguration, RA problems, maximum uplink transmission, synchronization failure, and T310 expiry. So, for example, here you can see we have here 4% for the master NLP, which is very low, and this is usually due to the downlink and maximum transmission and also sometimes transport issues. So here is 4%, and here we have this one. Sorry, we have 96%, and this one we have 4%. And this is master NLP. Whenever the UE report SCG failure to the master NLP, the master NLP will release a connection. So the breakdown of this 96%, as you can see here, for these causes, the highest one here is T210 expiry. So in this case, for example, you can look into the, for sure, try to optimize first the condition, radio condition, or you can also tune this T310 related timers. And the second cause is CGNB triggered, which means the second renew is triggering the release. Here, for example, it's majority during radio. And in general, this is having 2 causes, even UE connection lost and uplink synchronization issue. And this also controlled by one of the timers, or it can be downlink maximum retransmission for RLC being reached as well. This is also one of the cases. And the second one can be due to transport, transmission issues, for example. This data is just for visualization, it's not real data. So for sure you will find completely different figures maybe in your network, and it will differ from one network. So this can also be used for the breakdown analysis. Next slide, actually, here just summarizing the high-level parameters which you would like to look into whenever you're trying to optimize the drop rate. For example, here in the top left, it's showing the RACH problems. Here it's showing the RACH format. In other words, we can see RACH planning. For example, you have short format, long format. For example, we have seen a good experience when you change from short to format, long format, especially non-standalone, which is giving a very good improvement in the success rate. and for sure there is a trade-off always from changing from long to short or short to form. And as you know, this is being introduced in 5G in general. And also sometimes you'll find that some of the cells crossing the cell radius. So in this case, maybe you need to change the cell radius to be able to have a successful match, which will be reflected in the code drop rate. And some cases you would like to increase the power, maybe from some of the edge sites. Also, maybe you can change the preamble transmitted maximum. For example, how much preamble can be or retransmission the maximum. Also, the power ramming step. That what is the kind of increasing the power in steps, what kind of steps you would like to do. So you can also tune this kind of related parameters, which is actually this ratch settings is already available in 4G, and I think you might be aware about it. Then moving here for the layering tuning. The good point is that in 5G standalone, you don't have many things to tune in the layering. For sure you have, but not that much, especially if you're talking about the 5G. So I have listed the top here. For example, you have E2 RSRB for SGNB release. If you remember, I explained at the beginning that there is this released due to network desirable or radio desirable reasons. For example, the E2 that was is controlling the removing of the CGNP release. For example, like you are assuming that sometimes you're keeping till very bad level 121. So this can lead into the drop, right? So you can relax a little bit to try to remove it at, at early stage to avoid any drop. Also B1 threshold, same concept. This is for addition, this is for removal. For example, you are adding till neg 125 or neg 128 or whatever. So you can also try to tune this part to ensure that you are adding the the 5G whenever you really you can get the maximum benefit out of it. Then you can also control about the relative threshold for the SLA change. For example, to make early handover, to make it little bit late, depend also on your network. This is the common things for layering strategy. Then we have some tuning for downlink and uplink related RF issues. For example, for sure, first thing it will be about the optimization. It can be even power tuning, or it can be related to physical tuning. Then you have the downlink and maximum retransmission thresholds. For example, the RLC or HARC, how many times you would like for downlink and uplink. For example, you have 8, you can extend to 16, but at the end it's trade-off. So this is also based on your network setting, but so I'm just giving you an idea about that part. Then this is related to the issue of, remember, expiry due to T310. For example, you can play around these parameters to try to improve this kind of signature, which is T310 expiry. Then you have uplink time alignment timer. This is just to avoid the scenario where you have the drop due to uplink synchronization issue. This is, for example, as I told you, sometimes you find it infinity. You just need to check what is the abbreviate for network. Then you have BTCH beamforming feature in general can improve also the causes whenever you have a BTCH, for example, high blocker rate. This feature can improve the quality, and because it's giving a beamforming, so it can improve the SNR quality. So it can also reduce these causes which are related to 310 expiry because you will improve the quality. Then there is a cases about the abnormal devices. You have penalty timers, or maybe it will be a feature in the vendors. For example, in case if directly the user is triggering after the SGB successful addition, it will trigger directly, for example, reestablishment or trigger and keep making drop reestablishment directly after the addition, and again keeping adding and dropping, adding and dropping. So in this case, they can give a penalty timers to avoid this kind of particular users who's repeatedly added and removing or dropping the connection, to try to give a penalty for them to avoid adding this. And it can be, for example, for a particular carrier or whatever, and this can be done, or can be a particular feature of that. Also, you can collect all the abnormal devices in general. If you observe some signature which caused by specific devices, you can get the device information, as we mentioned also previously, from initial context setup request. For example, you can get the mask IMSV, and this also can get from SGB request, addition request. And this is, for example, you can request the core network to blacklist particular devices from accessing 5G non-standalone network, or you can do through SPID feature, which is called subscriber profile identity, and or you can do it through some other features from vendor related, where you can access this kind of prohibit the user from access non-standalone from the 4G RAM. And this is like a listing the most common parameters, and that's it for today's session. I hope if you like the session to press like and comment, and to share it with your friend and spread the knowledge. And most important, if you are looking for something specific or particular to be covered in the 5G non-standalone series, please drop it in the comment, so I will consider it in my next videos. Thank you very much, and see you next video.